Hello and welcome. Let's get right into this. So we have two intersecting chords. So we're going to be finding the lengths. So the property, the relationship of how these relate to each other is essentially take the small length times the larger length equals the smaller length of the other chord times the larger length of that chord, right? It's this proportionality that where you take the small times the large, it's going to be the same as if we take the small times the large in the other chord, right? So if we set this up, that's going to be 40 times 2x plus 7 equals 4x times 9x plus 11. Now, I don't know about you, but I like simplifying as soon and as possible as I can because if I start distributing 40 and 4, those are kind of larger numbers. So, first off, I would say, okay, is there something I can do to both sides that could tack this down to sides? Yeah. You'll notice that 40 and 4 have a common number, right? That's 4. Divide both sides by the same thing. We know that as long as we do one thing to one side and do it to the other, right, it keeps equivalent. So if I divide both sides by 4, let's see this magic happen, right? That means that on the right side, 4 over 4, they essentially cancel with each other, and it leaves you with x times 9x plus 11. On the left side, then we're left with 40 divided by 4. What is 40 divided by 4? 10. And then times 2x plus 7. And these are much smaller numbers to tackle. I can handle this by far more. Okay, so now let's distribute that x through, and we get 9x squared plus 11x. And distribute the 10, and we get 20x plus 70. Okay, far easier to deal with. Now, hopefully, bells are ringing as soon as you see a square anywhere. Your goal is to get everything onto the same side. You are going to be solving a quadratic. Okay, I like keeping my squares positive, so I'm going to move the 20x and the 70 to the other side. Okay, so those cancel, leave you with 0 equals 9x squared minus 9x minus 70. Now, at this point, you can solve this quadratic a myriad of different ways, right? The number one way that I would highly recommend, it's always that's my first go-to, is factoring. I love factoring, okay? But if factoring's not your cup of tea, you can use the quadratic formula, okay? And if you don't want to use quadratic formula, then completing the square is also a thing for you, okay? Now, if you don't know either of these two methods, factoring, it's your go-to, but what will always work is quadratic formula and completing the square. I'd recommend you know at least one. Okay, for this video, we're going to try factoring because I'm partial to it. Okay, your first step is to always look for GCF. Is there a number that goes into both 9 and 70? Unfortunately, no. So now we're going to be left with this little sizable of numbers here. Your middle is negative 9, so put that right there. And then our first times our last is negative 630. Okay, negative 630. So now we're at this interesting crossroads here. Let me make sure. Yeah, I wrote that down right. Okay, so now we're at this interesting crossroads where we are going to be multiplying numbers up that multiplying two numbers that okay, hold on. Finding two numbers that multiply to 630 and add to negative 9. Now, what can help us here? 630 is gigantic, right? But we know that if we're adding to negative 9, they have to be relatively close numbers, right? You can't have like 1 times 630 because that 629 is going to be the smallest difference between them. You're not going to get to negative 9 anytime soon. So what I would recommend is that if you have a factoring that's this large, break down your numbers, right? What's another way we can break down 630? Well, if that's 0 at the end, I'm tempted to use 10 and 63. All right? Now 10 and 63 is a little bit closer. If we do 63 minus 10, that's 53, but still nowhere near 9. So then I'd say, okay, well, what's some other ways we can break 63 down? Well, while we knew 630 was 63 and 10, what about 9 and 7? Okay, 9 times 7 is going to be 63, so maybe that works. So let's use, that means 9 and 70 or 7 and 90, right? Because whatever number we want to use, then you multiply the two remaining numbers, and that is also a factor, right? If you take this to your calculator, you'll get 630 both ways. Now you'll notice that this is a little bit larger. We're getting further from 9, so that means that maybe we want to break 9 down a little bit more, right? That's 3 and 3. Let's try a different combination. What about 7 times 3? That's 21. Alright, so if we do 7 times 3, that means that we have 3 times 10, which is going to be 30. Ooh. Oh, this is promising. This is promising. All right. We know that it's negative 630, so that means at least one of these is negative. Tack on some negatives. And then if we add these together, we get 30 minus 21. Ding, 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 right? That's going to be a 9, right? But we're not looking for positive 9. We're looking for negative 9. So all we have to do, make it negative 30, positive 21, and that's going to give you negative 9. Huzzah! Right? And that is what we need. So that means we have positive 21, negative 30 are our numbers, and you are now good to go. Alright? So, from here, the reason why we add to our middle number is because we replace our middle number in our original expression, so 9x squared, and then we would do plus 21x minus 30x minus 70. Okay, and now this is factoring by grouping, right? This sucker equals 0. Split right down the middle. Be careful not to split your sign. Okay, and now you say, right, in the first term we have a 3x in common, which leaves a 3x plus 7 behind. In our second group, we have a negative 10 in common, which will leave a 3x plus 7 behind. Okay, your two parentheses are uncommon, so we do one more pull out. 3x plus 7 comes down. And when that's gone, it leaves your 3x, and when that's gone, that leaves your negative 10. And you have officially factored it. Okay, a little bit of work, but not too shabby, right? And then you do your very last step, set each factor to 0, so 3x plus 7 is 0, 3x minus 10 is 0. And then solve those equations. So the first one, we would subtract 7, then divide by 3. And the next one, we would add 10 and divide by 3. And that means that negative 7/3 and 10/3 are your solution, right? Now, are you done? No. Okay, you're close. You're so close to being done, right? Once you have more than one solution to x, you got to make sure that both of these solutions work out. Because think about it this way. All right, once you plug in your x value, you want to make sure that it works within your original diagram. Now, what kind of numbers are going to fail? Well, think about it. If you have lengths inside of a circle, can lengths be negative numbers? No. So when you plug in your two values, so we have negative 7/3 and 10/3, we've got to make sure that it comes back positive, right? And not just one length, but in all of the lengths. So first off, let's check our negative 7/3, right? If we plug that in for our x value here, let me know here. Is 4 times negative 7/3 going to be a positive number? No, right? A negative times a positive will result in a negative number, which means 7/3, negative 7/3 kicks the bucket, right? It's gone. Cross it out. We no longer care about that being a solution because it literally does not work, right? We don't have to plug it into any of our other x's because as soon as it fails once, it's going to fail. Okay? Now for the other ones, this is actually a pretty easy check. They're going to actually work out in all three of them. If we plug in 10/3, what's a positive times a positive? A positive, right? Checks out in that one. If we plug in a positive here, what's a positive times a positive? A positive plus another positive number, still a positive. You're good to go, right? And then here, positive times a positive plus a positive, right? So much positive. You know none of them are going to be negative lengths. Do you care what the lengths are? No, not unless it's specifically asking for it, which it's not. It's just asking for x. You just want to make sure it works out. Now, it's possible that both solutions will work. It's possible that neither solution works. Or, in this case, like what we had here, maybe one solution works. You have to double check them in all of your expressions that have an x. The reason why we didn't plug it into 40 is because is there an x to plug it in there? No. And that would be why. Okay, not too shabby, a lot of work when it came to that factoring, but honestly, if you know how to solve quadratic, that's not too bad there. Alrighty, thanks for watching.